Good morning, students. So I think all of you understood the last few examples, is not it? How to find out the conjugate or the quadratic equation, or how can we find out the imaginary roots. So now today here we discuss some examples, and the first example is here. What you have to do, we have to find out the modulus. If you see the question here, and the question is given like in this way, we have to find out the modulus and here argument, isn't it? And the first question is given here, fx equal to, first one is 1 plus I divided by 1 minus I. So the first question is this one here. So in this case, what you have to do, let's see here. The first one is here, the complex number is given. So the complex number is given 1 plus I divided by this one is 1 minus I. And what you have to do, we have to find out the modulus and argument. That means modulus means what? We have to find out R, and arguments means what we have to find out the theta, isn't it? So now in this case, what you have to do, first of all, if you see this question is not given in general form here, a plus ib. So the general form of a complex number is what? A plus ib. So this question is not given in a plus ib form. So that's why first of all, what you have to do, we have to rearrange this result, and then after that we have to find out the modulus and argument. Is it clear? So now let's see how can we do this one. So in this question here, first of all, to eliminate this I from the denominator, what you have to do, we have to multiply it by their conjugate. So that's why the question is given here 1 plus I divided by this one is 1 minus I. So if you multiply it by their conjugate, so 1 plus I, we have to multiply here, the conjugate of 1 minus I is what? 1 plus I. To balance this result, we have to multiply this one by numerator also. So that means here 1 minus I, 1 plus I we get. So ultimately, if you see here, it is of the form a minus ib, a plus ib. So obviously we know the value of this result, and this one is, we can write a square plus b square. So that's why a square means here 1 square and b means also 1. So that's why we have to write 1 square plus b square. A plus b into a minus b, we get the result a square minus b square, is not it? But in this case it is a complex number, so that's why what we get here, a square plus b square we get. So after writing this one, now if you see the next part here, so if we multiply this 2, if we multiply this 2, 1, we have to multiply the whole result, so that's why we have to write 1 plus I. Clear? 1 into 1, 1 into I. So next one is plus of I. So I, we have to multiply this whole result, so I into 1 I. Then second one is I into I square. So that's why we have to write this one is I square. Is it clear? So this one we write. So ultimately, if you see from here, so 1 plus 1, this one is 2. So here I square means what? I square means minus 1. So minus 1 plus 1, easily we can cancel. So what will remain here? I plus I, twice I. So that's how we get here simply twice I. So 2 cancel. So here simply remain I. You see here only remain I here. So that means if we convert this one into a plus ib form, then what you have to write? 0 plus 1 into I. So this one is the complex number here. I means simply what we can write here, 0 plus I, 1 into I. So that means this one is a complex number here, and this complex number we have to find out. For this complex number we have to find out the modulus and argument. Is it clear? So all of you know how to find out the modulus and argument here. So for that reason, what you have to do, this one is the real part and this one is the imaginary part. So real part equal to r cos theta, and imaginary part equal to what you have to write? R sin theta we have to write. So that's why you have to write here. First of all, you see here, let r cos theta. So let r cos theta equals to 0. We put this one is equation number 1, and the imaginary part, this one we have to write r sin theta, and r sin theta we have to write 1 here, and this one we have to write equation number 2. Is it clear? So after that, all of you know what you have to do. 1 square plus 2 square, is not it? 1 square plus 2 square implies. So if you squaring and adding, lots of question we have done here. So that's why here r square cos square theta, r square sin square theta. So that's why r square common, and then we have to write this one is cos square theta plus sin square theta, is not it? And from here 0 square plus 1 square, ultimately the value is what? 1 here we get. And this one, from here we get r square equals to 1. If we take the square root, then we have to write r equals to 1. Actually we get here 2 result, plus minus 1. Since modulus always positive, so negative is not possible. So that's why simply we have to write r equals to 1 here. Is it clear? So in this way we can find out the value of r. So in second part, what you have to do, we have to find out the value of theta. For theta, all of you know what you have to do. 2 divided by 1. Lots of time we have done this one. So 2 divided by 1. So r sin theta divided by r cos theta. So that's why we have to write this one is r sin theta divided by r cos theta equals to, now if you see here, the r sin theta value is 1. So that's why we have to write this one is 1 and this one we have to write 0, r cos theta. So from here r cancel, sin theta by cos theta means this one we have to write tan theta, and 1 by 0. All of you know the value of 1 by 0. So 1 by 0 is undefined, isn't it? So 1 by 0 is undefined because 1 is not divisible by 0, isn't it? So that's why we have to write undefined. So in this case, this value, if we write here tan theta equals to this one, you have to write here undefined. So when we get the value of tan undefined, so obviously pi by 2. So tan pi by 2 equal to undefined, infinity, isn't it? So that's why we get theta, tan theta equal to tan pi by 2. So in this case, if we check out here where the coordinate lies here actually, so the general form we get 0 plus 1 into I or I into 1. So in this case you see both values are what? Positive. So if both values are positive, that means which quadrant? So obviously in the first quadrant. If both values are positive, so obviously lies on first quadrant. So if lies on first quadrant, that means in between 0 to pi by 2. So simply here pi by 2 we get. So therefore we can write here theta equals to, simply we can write here pi by 2. So this one is argument. Is it clear? So here modulus equal to we get 1 and argument equal to how much here? Pi by 2. I think all of you understood this one. Now after completing for the first one, the second one is here given 1 divided by 1 plus I. So that means in this case the second question is, if you see here, the second question is given 1 divided by 1 plus I. So this one is the question here. So in this case again, if you see here, the question is not given in standard form of a plus ib, is not it? 1 divided by 1 plus I. So what you have to do first here? So first of all we have to rearrange the result, and we have to rearrange this result in the form of a plus ib. Then we can find out the argument and modulus here. Is it clear? So that's what you have to do. Very simple. So here 1 divided by 1 plus I is already mentioned. So we have to multiply it by their conjugate to rearrange this result. So if we multiply it by their conjugate, then we have to write 1 minus I. To balance this result, we have to write here 1 minus I, because these two cancel again remain same. So now if you multiply these two, so it is of the form a plus ib and a minus ib. So that's why we have to write here a square plus b square. So that's why 1 square plus 1 square we have to write, and in the numerator part we have to write 1 minus I. Is it clear? So in this case you see here, this one we get here 1 minus I divided by 2. 1 plus 1, 2 here we get, and finally we get this one. If we arrange this result, 1 by 2 minus of this one we get here 1 by 2 into I. Is it clear? So this one is a complex number here. It is of the form a plus ib, 1 by 2 and 1 by 2 into I. So that means here the real part means 1 by 2 and the imaginary part is what? Minus 1 by 2, isn't it? So here real part and imaginary part we get here. So now after getting this one, now we have to convert here this one, not polar form, we have to find out the modulus and argument. So that's why real part equal to r cos theta we have to consider, and imaginary part equal to we have to write r sin theta. So that's why here we have to write let r cos theta. So r cos theta equals to, we have to write this one is 1 by 2. Is it clear? So r cos theta equals to 1 by 2 we have to write, and then second one we have to write r sin theta. So r sin theta we have to write here minus of this one is 1 by 2. So r cos theta and r sin theta we write here, these two are the results. So after that we have to put this one is equation number 1, as well as we have to put this one is equation number 2. And then what you have to do here, we have to squaring and adding. All of you have know what you have to do. 1 square plus 2 square we have to write. So this implies, now in this case you see here r square cos square theta, r square sin square theta. So that's why r square is common here, and then we have to write this one is cos square theta plus this one we have to write sin square theta. Is it clear? R square equal to into cos square theta plus sin square theta. And which one we have to write here? In the right hand side, if you see 1 by 2 whole square, so 1 by 2 whole square, this one you have to write 1 by 2 whole square. Is it clear? Plus and minus of 1 by 2 whole square. Is it clear? So this one we have to write. Now after that, if we calculate this one, so here remains simply r square, because cos square theta plus sin square theta is what? 1. So here 1 by 4, 1 by 4. That means what you have to write this one. This one we get 1 by 4 plus 1 by 4. If we calculate this one, 2 by 4, 2 times of 4 here, 2 by 4 means ultimately here we get r square equals to 1 by 2. If we take LCM, then we get here 2 by 4. 2 by 4 means simply 1 by 2, and ultimately here we get, therefore r equals to how much? R equals to, we get here 1 by root 2. Is it clear? So the modulus value is this one, r equals to 1 by root 2. I think all of you understood this one. So this one is the modulus part, and next we have to find out the argument part here. So in argument part, all of you know what you have to do, 2 divided by 1, isn't it? So that's why we have to write here, this one is equation number 2 divided by this one is, we have to write equation number 1. And 2 divided by 1, in this case we have to divide this one, and that's why we have to write what? R sin theta divided by R cos theta. So that's why we have to write this one is R sin theta, and this one we have to write R cos theta equals to, this one is what? R sin theta means what? Minus 1 by 2. So that's why we have to write this one is minus 1 by 2, and this one we have to write 1 by 2. Isn't it? So we have to cancel these two, and finally what we get here? R cancel, sin theta by cos theta means what you have to write? This one you have to write tan theta, and tan theta equal to minus 1 by 2, 1 by 2 cancel, so simply here remain 1. So in case of tan, when we get 1, so 10 pi by 4, so that's why we have to write here tan theta equals to minus is remain same, and in place of 1 we have to write 10 pi by 4. Is it clear? Now after that we have to find out the angle. For angle, what you have to do, first of all, if you see here where the value lies, that means the value, whatever the result we get, where lies. So the complex number we get here 1 by 2 minus of 1 by 2i. So in this case you see here the real part, x is positive, isn't it? X is positive and y is what here? Negative. So that means in this case positive, and here it is negative. So that means in this quadrant it lies, that means fourth quadrant. In fourth quadrant tan is what? Negative. So in this case what you have to do, we can easily consider the negative angle here, because if we measure from here it moves 90 90 90, then we get this angle, is not it? So if we measure from here, then we can easily calculate here, because in fourth quadrant if we move in negative direction, then easily we can calculate the angle. So that's why here the angle is what? Pi by 4, and tan theta equal to minus 10 pi by 4. So that means from here tan theta equal to what? Theta equal to what we can write here? Minus pi by 4. Is it clear? So this one is the argument here. So this one is the argument, and this one is modulus here we get. Is it clear? I think all of you understood this one. So in this way, very easily, if a complex number not given in a plus ib form, so after converting this into a plus ib form, in this way we can find out the modulus and argument. I think all of you understood this one. Is it clear? After completing the question number 13 here, now next one is, if you see the example number 14, and the question is given like in this way. If you see here, a complex number is given, x plus iy equals to what given here? A plus iv divided by a minus iv, isn't it? And what we need to prove here? We need to prove here x square plus y square equals to 1, isn't it? So let's see how can we prove this one. Very easy and simple question. First of all, what you have to do, whatever the question is given here, x plus iy equal to a plus iv divided by a minus ib. So this a plus iv divided by a minus ib, we have to convert this one into a plus ib form. So now first of all, what you have to do, whatever the question given here, the question is given here this one, x plus iy. So x plus iy. So x plus iy equals to, this one is given a plus ib. So a plus ib divided by a minus ib. This one is given. So x plus iy equal to a plus ib divided by a minus ib. So now what you have to do, we have to convert this one into a plus ib form first of all. So what you have to do, we have to multiply it by their conjugate. So if we multiply it by their conjugate, so that means here if you see the denominator part, denominator is a minus ib, and the numerator is here a plus ib. So if we multiply it by their conjugate, so conjugate is what here? A plus ib. So that's why we have to write this one is a plus ib. To balance this result, we have to multiply it by here also the a plus ib. So these two cancel, again remain same, isn't it? So now after multiplying by their conjugates, so if you see here a plus ib into a minus ib, so directly we write here a square plus b square, isn't it? So now in this case, if you see here, if we multiply these two, so if this a we have to multiply with this whole result, so that's why what you have to write a plus, or we can write a plus ib whole square also we can write, or you if we multiply this one a into a, that means here this one we get a square plus a into ib, that means I a b, plus second one what we get ib into a, that means this one we get I into a b, and finally this one is I into I square, so that means we write here I square and b into b square. Is it clear? So this one we write here. So after getting this one, now this one is a square plus b square. So if a square plus b square we write here, if you see here, what is the value of I square? I square means minus 1. If I square is minus 1, then simply this one remain minus b square. So a square minus b square we write at first. That's why we have to write here a square minus b square, because a square here I square means minus 1, so that's why minus b square, so we write a square minus b square first, and then plus I. Then if you see here ab plus ab, that means 2 times of ab, so that's why I into 2 times of ab. Is it clear? So this one we write here. I think all of you understood this one. So now if we convert this one into real and imaginary part, so this part a square minus b square we consider a real part, and this one is twice ab. We have to separate this one. So in this case what you have to do, let's see here, the left hand side is here x plus iy, the left hand side is x plus iy, and the right hand part what you have to write a square minus b square divided by a square plus b square. So that's why we have to write this one is a square minus b square divided by, we have to write this one is a square plus b square, plus now in this case you see I twice ab divided by a square plus b square, so we have to write this one is I, and this one you have to write twice ab divided by a square plus b square. Is it clear? Is it clear? So the first part a square minus b square divided by a square plus b square we write, plus I into this one is twice ab divided by a square plus b square we write. I think all of you understood this one. So this one is the real part, imaginary part. So x plus iy equal to, we get this result. So we put this one is equation number 1. Now if we multiply, or if we find out the conjugate of this x plus iy, so what is the conjugate of x plus iy? So if we write down the conjugate here, we have to write x minus iy. The conjugate of x plus iy is what? X minus iy. So that's why what you have to write here, a square minus b square. So that means this one you have to write a square minus b square divided by this one we write a square plus b square. And if we write down the conjugate here, we have to write minus I, this one is we have to write twice ab divided by a square plus b square. So without comparing we can directly write also this one like in this way. So we put this one is equation number 2. Is it clear? So here this one is a complex number x plus iy, and the result is like in this way we get. And if we write down the conjugate x minus iy, so x minus iy, that means in this case also we have to write minus here. I think all of you understood this one. So now if you multiply 1 and 2, now if we multiply this 1 and 2, 1 and 2, if we multiply these two, what we get? If you see here, the left hand side is x plus iy, x minus iy. If we multiply these two, then obviously we get here x square plus y square, which one we need in the result, isn't it? So that's why we write here, if we directly write here, then the result we get here x square plus y square. I think all of you understood this one, x square plus y square. So 1 and 2 we have to multiply. So a plus ib form, a minus ib form. So x plus iy into x minus iy. So if you multiply these two, so simply we get here x square plus y square. And in the right hand side, if you see here, again you see the same results are here. So this one is if we consider x, if this one is we consider y, this whole part is x, this whole part is y. So again it is of the form x plus iy, x minus iy. So what you have to write? X square plus y square. So x means what? This whole part. So that's why we have to write here a square minus b square divided by a square plus b square whole square, plus then the right hand side, this one is we have to write twice ab divided by a square plus b square whole square. Is it clear? A plus IB into A minus IB, if we multiply it by their conjugate, then we get this result. Left hand side, right hand side. I think all of you understood this one. Now here, after that, left hand side we get. Now we need to prove what? This part is equals to 1. So if you calculate this result, I think here, how can we calculate this result? If you see one more line here, so left denominator we can write a square plus b square whole square, isn't it? So in numerator, if you see here, this one we can write here a square minus b square whole square, and this one we can write here, what we write, 2ab whole square. That means 4 times of ab whole square we can write, or simply we can write this one is, you see here, 4a square b square. If you break this result, clear? I think now all of you understood this one. So a square minus b square plus 4a square b square result is what? A square plus b square whole square. If you not understood this one, then what you have to do? You have to break this one in the form of a minus b whole square. So minus 2a square b square we get, and this if we calculate this one, and after that if we calculate this one, then simply we get here as a whole the result is what? A square plus b square whole square we get. So a square plus b square whole square, as well as in denominator also a square plus b square whole square is there. So if we calculate these two and if we cancel these two, so finally the answer is what we get here? We get 1 here. Is it clear? I think all of you understood this one. Okay, so in this way we complete this question, and whatever the proof we need, this proof is what? X square plus y square equal to 1 we need to prove, and this one we get here. So in this way we can prove this result. Is it clear? Okay, so in our next class the remaining example questions we have to do. So your task is what? You have to practice these 3 questions, or if any question or any queries are there, then you can ask me. In our next class we have to continue the example from example number 15. Is it clear? So in this way we have to continue these examples, and after that we have to complete the miscellaneous questions also. Is it clear? Okay, thank you.